This is the sheet over which the positive charge is distributed uniformly. Sigma 1 is the surface charge distribution. Density means charge per unit area. Sigma 1 means that how the charge is distributed over this area. Now because of this sheet, if you put it in a unit positive charge, it will move along this side. So there's a direction of E1. Okay. Now this sheet is also positive. Here this sheet is, over this sheet, again the positive charge distribution, and is determined by sigma 2, is surface charge density for sheet, you can call it B, sheet B. Sigma 2 is the surface charge density over the sheet B. Now if you put it a unit positive charge here, because of this sheet, this sheet, it will be repelled along this side. So this will be the direction of E2. Now what will be the E1? By using the Gauss theorem, it is sigma 1 upon 2 epsilon naught, and because of this sheet E2, sigma 2 upon 2 epsilon naught. Because both are along the same direction, total intensity becomes the sum of the two. Now coming this region, because of this sheet sigma 1 charge distribution, the electric intensity will be along this side. Because of this sheet, if you put a unit positive charge, it will be repelled along this side. So this is E2. Okay, E2 because of this sheet, sigma 2 upon 2 epsilon naught. So E1 means sigma 1 upon 2 epsilon naught. Again both are along the same direction. Total intensity becomes the sum of the two. Now coming in this region, secant, if I put a unit positive charge here, because of this sheet, it will be repelled along this side. If I put a unit positive charge here, because of this sheet, it will be repelled along this side. Now E1 and E2, they are along opposite in direction. So what about the net intensity? And we are thinking sigma 1 is greater than sigma 2. So this intensity will be greater in magnitude, and this intensity will be less in magnitude. So the resultant intensity becomes E1 minus E2, and the resultant intensity will be, the direction will be along which is the bigger one. The bigger one is the E1. So net intensity will be also along this side. Okay, and it will be E1 minus E2. So you show E1 with a bigger length, E2 with a shorter length. Like if this is 10 centimeter, this is 2 centimeter, the resultant intensity becomes 8 centimeter along this side. Okay, so it depends if sigma 1 is greater than sigma 2, then. Okay. Now this is the case number, second case. For this case, we are thinking like this sheet is positive, the positive charge distribution, and is given a name like assigned by a parameter sigma 1. Sigma 1 is the surface charge distribution over the sheet, and it is called like charge per unit area, and it is positive. Now here the charge is negative, and the negative charge distribution is assigned by sigma 2, again the charge per unit area over the sheet, and again we are thinking sigma 1 is greater than sigma 2. Now because of this sheet, the intensity will be this side. Okay, because of this sheet, this is negative. If you put a unit positive charge, it will move along this side. So E1 and E2 now opposite in direction because this sheet is negative now. And net intensity becomes E1 minus E2. Okay, and again by using the Gauss theorem, sigma 1 upon 2 epsilon naught, sigma 2 upon 2 epsilon naught, and E1 minus E2. Now in this region, if you put unit positive charge, because of this sheet, it will be repelled along this side. You put a unit positive charge, because of this sheet, it will be attracted along this side. Again, they are opposite in direction. So that's why resultant intensity will be the subtraction of the two are given here. Now coming to this side, because of this sheet, positive charge, it will move along this side. And again put a positive charge, because of this sheet, it will move along this side. So both are along the same direction. The total resultant intensity will be the sum of the two now, E1 plus E2. Okay, this is different if the one sheet is positive, other sheet is negative. Okay. Number 3. Let me suppose that sigma 1 is equals to sigma 2, as well as here the positive charge distribution, here negative charge. Okay. And again sigma 1 means the charge per unit area, and sigma 2 again charge per unit area, and both in surface charge density they are equal in magnitude but opposite in sign. So you put a unit positive charge here. Because of this sheet, it will be repelled along this side. You put a unit positive charge here. Because of this sheet, it will be attracted along this side. Now this, repulsion and attraction, they are equal in magnitude and opposite in direction. That means subtraction. Subtraction means sigma 1 minus sigma 2 upon 2 epsilon naught. And as sigma 1 and sigma 2 they are equal in magnitude, resultant intensity becomes 0. Similarly here, positive charge because of this sheet will be repelled. Positive charge because of this sheet will be attracted. Opposite in direction, same in magnitude, resultant intensity 0. Put a positive charge here, because of this sheet will be repelled. Put a positive charge here, because of this sheet will be attracted. Now they are both same direction. So same direction means the addition. Total intensity becomes the sum of the two. Okay. So E1 plus E2, sigma 1 minus sigma 2 upon 2 epsilon naught, they are equal. That means 2 sigma upon 2 epsilon naught. That means sigma upon epsilon naught. Okay. Now we are coming in the case like we know very well, if this is a sheet and sheet is very thin, that the same charge appears on both the sides. Mean this positive is this to this side as well as this positive. The same positive is appearing to the back side. Now in this case, if you are interested at this point about the field, it will be sigma upon 2 epsilon naught. Sigma 1 is the surface charge density. But if the sheet is thick, like thick sheet, the same charge is not appearing on both the sides, then what happens? Like this is a sheet, okay, and sheet is thick. The sheet is thick, right, and positive charge on the front side. This is the front side. The blue color back side, again positive charge. Now first of all, E intensity because of the black charges, sigma upon 2 epsilon naught. Because of blue charges, again sigma upon 2 epsilon naught. Because both are along the same direction, okay, both are along the same direction, so they will add up and becomes simply sigma upon epsilon naught. So this is the formula of the resultant intensity in that case when the sheet is thick. If the sheet is very thin, infinitely small thickness, then sigma upon 2 epsilon naught. If the thick sheet, the different charges on both sides, then sigma upon 2 epsilon naught. Okay, thank you.